Welcome to today's lecture. Today we are going to continue from where we had left in the previous lecture. Today we are going to learn how to determine the elastic forces associated with the machine foundation vibrations and how to make use of them in finding the soil pressures. So as far as the elastic forces are concerned, the main medium which comes into effect is soil. Soil acts as the elastic medium and basically is the spring that carries the elastic forces that we are going to now compute. In a given situation, the foundation system is under various types of loadings from the machine. Accordingly, it is under various kinds of vibrations. For example, the vertical vibrations, horizontal vibrations, and also rotation and yawing. So rotation referred to as rocking and pitching. So here we are drawing the vertical springs represented by the stiffness of soil in the vertical direction, that is the z direction, and this is kz. Similarly, in the horizontal direction we have the soil spring stiffness k tau x or kx. For rocking, the related spring stiffness is k theta y, which is shown here. In addition to these springs, there will also be the spring stiffnesses associated with yawing and pitching. As we have studied before, the vertical vibrations are independent. So for vertical vibrations, basically the elastic forces are induced in the vertical direction. So the elastic forces in the z direction represented by Fez, where we are using the subscript E for elastic and Z to mean that they are in the vertical direction, are given by the product of Kz, the spring stiffness in the vertical direction, and the displacement amplitude Az0. In addition, the force is multiplied by the fatigue factor equal to 3 to take into account the fatigue effects. For the combination sliding and rocking, elastic forces are produced in x direction. In addition, elastic moment is produced about the y-axis. So the elastic force in the x direction, denoted by Fex, is basically the product of the spring stiffness k tau x, the net displacement along the contact surface between the soil and the foundation, and finally the fatigue factor. On similar lines, we can write expression for the elastic moment MEY, and this would be given by the product of the rotational spring stiffness k theta y, the angular amplitude a theta y naught, and the fatigue factor. Once we have the values of Fez and MEY, we can check for soil pressure. Now, because the soil pressure is in the vertical direction, Fex does not come into picture. So we have to find the total soil pressure in gross sense, and that should include both the static and the dynamic components. So static component is caused by the static dead loads and the equipment loads and other live loads. So for that purpose, we divide the total weight by the area of the base of the footing, and then we have the static moment. So static moment should be divided by the section modulus about the y-axis, and sometimes the symbol for section modulus is Z, or it may be ZF. So this is the expression for the first component, the static component, and then we need to find the expression for the dynamic component. For dynamic component we use plus minus sign, so we have to check for both the vertical force as well as the moment. So for the vertical force we are dividing by the area of the footing to get pressure, and for the moment part MEY we are again dividing by the section modulus of the base of the footing. For section modulus Z, it's very customary to use the subscript F to highlight that it is for the foundation. Now comes the final check. So we have assumed some sizes of the foundation, and then we have done these calculations. So at the end, the maximum pressure and the minimum pressure, they should be such that the minimum pressure is greater than 0, that is there is no tension anywhere, and the maximum pressure is within 80% of the allowable gross bearing pressure. Once the calculation part is over, the next component is the preparation of the drawing, and the drawing of the foundation should show the details of the reinforcement. So we'll just study here some of the requirements for reinforcement detailing for block type foundations. This is in accordance with IS 2974 part 1. The block type foundations are mainly subjected to rigid body vibrations, and then the different projections, they need to be checked for adequacy at the critical junctions for inertial forces, which we have already studied. Typically we need to provide reinforcement along the entire periphery of the foundation. Usually we use L-shaped bars or C-shaped bars. We need to do overlapping of the adjacent bars so that adequate development length is there. Often projections which are like vertical cantilevers, they stem out from the main block, and in such situations it's also necessary that the rebars, they have adequate anchorage within the main block, and for that purpose their length of embedment should be at least the development length. Similar reinforcement needs to be provided in the other direction. This is visible here in the form of the dots. The drawings must show the exact dimensions for the embedment of the rebars as is shown here for the projecting part. The clear cover to reinforcement as per IS 456 has to be 75 mm. Now the clear cover really depends on the exposure conditions. So for mild exposure conditions, suggested will use 75 mm. Higher cover may be provided for more severe exposure conditions as per IS 456. Typically It is customary to provide 12 mm diameter bars at a usual spacing of 200 mm center to center. This is more than adequate. The critical sections, for example the one shown here, must be checked for adequacy against bending moment and shear force caused by inertial forces. This we have already studied, how to find out the moment and the shear force, or if axial force is applicable, then how to do that for such projections. So the reinforcement should be sufficient to resist these forces and moments. In any case, the quantity of the reinforcement should not be less than 25 kg per cubic meter of the concrete. But in case the foundation is supporting pumps which are basically pumping explosive gases or similar kind of fluids, then it's recommended that the quantity of the reinforcement should not be less than 40 kg per cubic meter. Though in most of the situations the peripheral reinforcement along all the sides of the foundation, such as 12 diad 200 mm center to center, is sufficient. However, if the block size is very large, then we may have to provide reinforcement inside the block also, so that it's within the minimum requirement of 25 kg per cubic meter or 40 kg per cubic meter, as the case may be. Now, as per IS 456, the minimum grade of concrete to be used should be M25. So for other provisions we must refer IS 456 and IS 2974 part 1, especially clause 5.4.5 for reinforcement detailing. In the end, we just summarize all the design steps. The first step is that we have to do frequency ratio check, that the frequency ratio is not falling in the undesirable zone, 0.4 to 1.5. Then we have to calculate the amplitude of the vibration, and the vibration amplitude should be less than the value specified by the manufacturer to ensure proper functioning of the concerned machine. Then we have to make sure that the provisions of IS 2974 part 1 with respect to the comfort of the occupants or the users, and also the provisions with regard to the safety of the structure. In any case, the vibration amplitude should not be permitted in excess of 200 microns or 0.2 mm. After vibration amplitude check, we must do check for the soil pressure. So allowable net bearing pressure of the soil should not be exceeded. And then we also need to check the critical sections for inertial forces. So the critical sections should be adequate with regard to reinforcement as far as the action of the inertial forces is concerned. And finally, we need to provide all reinforcement detailing in drawings. As a practice exercise, you are required to complete the design problem which we had covered during our tutorial 1 and apply the steps number 3, 4 and 5. So thank you very much. If you have any questions, you can discuss them during our interaction in the MST.